Good evening everyone, welcome to the one problem a day, and today is the 17th October 2024 solution which we are doing. Okay, so let us start this with this one. This is for the IB1 students. IB2 students, I already posted a video for you. Okay, so you're supposed to look into the second one. Maybe probably we can also look into this. Okay, so this will give you a better revision on understanding the electrostatic charges, and also there is a small portion of this problem which deals with the EMI, electromagnetic induction, and capacitances. Okay, so there are usually in IB what happens is there are two chapters which can be, the questions can be linked to both the chapters. Here is one such example where the question has been linked to both. So very much suitable for the HL students. Okay, now let us begin with this. So this question is for 11 marks, and so I have allotted the timings to be around 11 minutes over here. Let us try and see whether we are able to solve it in 11 minutes. Many times we have not kept the promises. It keeps on delaying. The reason is because I need to explain. I cannot just be solving the problem. Okay, and if I want to solve, I can solve it within 8 minutes also. Okay, but since I want you people also to solve, to understand the flow of how the ideas emerge, so as a result of it, I need to prolong it a little bit. Okay, anyway, now let me proceed with this. So let me start the timer. Two equal positive charges of point charges Q equal to 44 microcoulomb. Okay, 44 microcoulomb, and point P are the vertices of an equilateral triangle of 0.48 meters, which means what? This side, and this side, all of them are at a distance of 0.48 meters. Okay, let me write it down here, 0.48 meters. Okay, and this point P does not have any charge, only here this has a charge. This is 44 microcoulomb, this is 44 microcoulomb. Okay, what's the next step? Then show that the magnitude of the resultant electric field at P is 3 million Newton per coulomb. Okay, we need to find what is the electric field at this point. Now, how do I find? Now, what will happen? Now, the electric field at this point, due to this positive charge here, will be in this direction, and due to this charge, it will be in this direction. Why is it like this? Because radially outwards, right? So, this charge will now produce the electric field in this way, radially outwards. So, one of these field line will be like this over here. For this one also, it will be like this over here. Now, this, since it's an equilateral triangle, this angle is 60, this angle is also 60. If this is 60, then, and these two are like this, what I can do is I can now draw a vertical line like this and a horizontal line like this. Why did I do it? Because I wanted to resolve this electric field vector, because electric field is a vector. So, I am going to resolve this. So, therefore, let the electric field due to this charge be E, due to this also be E. Now, what is the angle made by this electric field vector with respect to the horizontal? See, for example, if this angle is 60, this is 60, see, between this line and this line, the angle is 60. It is like this, see, between this line, see, this peak over here, the point P here. So, therefore, if this angle is 60, this angle should also be 60. If this angle is 60, then the midpoint here, so this is the midline here, right? The midline over here, this will be 30. This will be 30. So, this angle is 30. If this angle is 30 and this perpendicular, this angle should be 60. The same is applicable here also, right? So, this angle is 30, this angle is 60. Okay, once we are done, then we can start resolving this vector E. How do I resolve this vector E? We resolve this vector E along this x-axis as E cos 60, right? And along this axis as E sin 60, correct? Or maybe E cos 30 or E sin 60. I have done it for one vector. Now, similarly, I will do it for this vector also. I'll do one thing, I'll just erase this IB1 here. Okay. Now, I'll try to do it for this also. So, this is your vector E. Along this direction, this will be E sin 60. Or first, I'll write here. This vector E along this direction is E cos 60. Under this direction is E sin 60. Now, what will happen? I need to take the resultant. Okay, the resultant means the sum of these two, because this point is now getting electric fields, contribution of electric fields from this and as well as this. So, therefore, see here, two electric fields are acting in the opposite direction. So, therefore, this electric field and this electric field will cancel, because here it is positive, here it is negative, it will cancel. Here what is happening? E sin 60, E sin 60. Total electric field is the sum of E sin 60 plus E sin 60, right? So, therefore, E total is equal to 2 times E sin 60. right? 2 times E sine 60, which is a total over here. Now let me come down here, show that the magnitude of the electric field. Now I will write down E total is equal to E times 2 times E sine 60. But now I need to substitute all the values. 2 into, what is the value of E? Now what is E here? E is the electric field due to one charge, right? See, this is the electric field due to one charge. This is another electric field due to another charge. So I just need to get the electric field due to first charge, because some of these two I already considered. Okay, I need not do it separately. I already done this one. Now I just need to get the value of E. How do I get the value of E? Simple. The formula of here E stands out to be K times Q divided by R squared. What is Q? The charge here. What is R? Distance between the point and the charge over here, which is 0.48. Now what I will do is, first I will lift myself and put over here. Okay, and now, and next what I do, I will take this one here, drop it over here. Now let me substitute here. So I will substitute here. E is equal to, what is K value? Electrostatic constant, 9 into 10 power 9. And what is the value of Q? 44 into 10 to the power of minus 6 divided by R. What is R? Distance, 0.48 square. 0.48 square. So when I do all this, what is the answer I get? Now what I do is, let me use my calculator so that I get the answer correctly. So now we have 9 into 44 divided by 0.48. I get this 825 divided by 0.48 once again. I get this 1718. I get this as 1718. And did we have any power there? We did not have any power. 1718.75 into here 10 power 9, here 10 power minus 6. It should be 10 cube. They both high, right? Okay. This is what we have. But what we need to do is, we need to substitute here. Only then you can get the total electric field. So this should be 2 into 1718.75 into 10 to the power of 3 into sine 60. What's the value of sine 60? Root 3 by 2. Okay. So when I substitute it over here, I'll put a line here to make it clear. Okay. When I substitute it for here, what do I get? I will take my calculator, not visible. Okay, fine. Okay, now multiply this by 2, multiply this by square root of 3, 1.73. I know this value. Divide this by 2. I get this as 2973. 2973 into 10 to the power of 3. Unit is Newton per coulomb, which should now be, if I write like this, I can write this as 2.97 into 10 to the power of 6 Newton per coulomb, right? See, here you had it 1000 over here, 2.97 into 10 cube. Already I have 10 cube, 10 power 6 it becomes. So this much I get R. This nearly becomes 3 into 10 power 6 Newton per coulomb. I can put a tilde here. Okay, R, this is nearly equivalent to 3 million Newton per coulomb. That is what is being asked, right? So we have arrived at this. Then, so this gives you 2 marks. State the direction of the electric field, resultant electric field at P. What is the direction of the electric field? What's the direction? Look at this. Resultant is upwards, right? So what you should write? You should just say direction is vertically upwards. Upwards. You can say so much. So this will be given 1 mark. Okay, next. Let us move on to the point. P is now moved closer to the charges. Earlier, it was an equilateral triangle, right? It was much farther here. It was somewhere over here. Now it is moved closer to this. Okay. Next, the distances d and d are here. X is known here. A point charge Q equal to minus 2 microcoulombs and mass 0.25 kg is placed at P. So I am going to put minus 2 microcoulomb here, and the mass of this is seen to be 0.25 kg. Okay. Then when x is small compared to d, x is small compared to d. Okay. The magnitude of the net force given by F is equal to 115x. 115, if it was just 115, it is constant force. It's proportional to x. Okay, what do you mean by F proportional to x? What do you mean by that? Okay, it says magnitude. Okay, no sign has been used, only so much over here. Which means what kind of force is this? This is a SHM, right? You have studied this in SHM. F proportional to x, Hooke's law you can use, right? SHM. Okay, acceleration proportional to displacement, force proportional to displacement. You can use this. Explain why Q will perform simple harmonic motions while is released. Now let us understand what happens to Q. When you put the minus 2 microcoulomb over here, what will happen? This Q will attract it like this. This Q will attract it like this. So what does it do? Because they are in equal distances, it's a perpendicular bisector. See, this is D and this is D. So it cannot go this side or this side. So it will now move to here. when it moves here, because why does it move like this? Because once again you are going to break this force into two parts, one force like this, other force like this, one force like this, other force like this. These two forces will cancel and you will only have these two forces added together. So the charge should move like this, resultant will be like this, it moves like this here. Now when it comes here, what happens? Once again it is getting attracted like this over here. Now it comes here, then what happens? Two forces are acting here, both our forces are equal and opposite, which means the force at this point is 0. Okay, make a note of this, force at this point is 0. When force is 0, what will happen to the acceleration? Acceleration is also 0. You have learned the similar mechanism even in simple pendulum. Simple pendulum, what happens? You have two extremities like this, two extremities like this. Now as the pendulum comes to the center, what will be the acceleration? Acceleration will be 0, velocity would be maximum. Here also acceleration is 0. Now when the charge comes to this point, then what will happen? It is being pulled like this. When it is being pulled like this, the velocity now reduces because resultant force is acting like this. When it comes here, resultant force is still acting like this, and at one point it stops. Then once again happens, what happens? These two starts attracting and it starts going like this. Thus the charge starts from here, it comes here, it moves here, then again comes here, then moves here. It keeps on performing SHM, right? Okay, now let us move on. So therefore we have understood the question, why should it perform SHM, right? Explain why Q will perform harmonic oscillations when it is released. So what do we write here? What do we write here? We should now write, what do we write here? We should now write, why does it perform? So F proportional to 115x, or F is equal to 115x implies force is proportional to displacement, first one. And secondly, you should also write force is attractive, and hence F is equal to minus 115x. Therefore follows the rule of SHM. You can write this also. Okay, so only for 2 marks. Or you can say force changes as it passes, we already crossed 11 minutes, through the point of displacement. What force change? The restoring force changes. What, not only the value, the direction also changes. So all these are characteristics of SHM. Therefore it is an SHM, right? You have to write it in detail. Whenever there is a question on SHM, you need to mention this. Okay, now calculate the period of oscillations of Q. So how do you write oscillations of Q? So what do we have here? F is equal to minus 115x. Now we know MA is equal to minus 115 into x. A should be equal to minus 115 divided by M into x. What is this equal to? This is equal to minus omega square x. So comparing these two, I can now write omega square equal to 115 divided by mass. What is the value of the mass? We already seen. Mass equal to 0.25. So this is 0.25. So how much will this be? Let us calculate this first to get the value of omega square. 0.25. So 115 divided by 0.25 will give me 460. 460. Thus, what's the value of omega now? Based on this, omega should now be square root of 460, which is 21.5. 21.5 unit radians per second. But what do I need? I don't need this one here. I want the time period. So how do I get time period? Time period is equal to 2 pi divided by omega, right? How do I get this? Omega is equal to 2 pi by t. This formula you are already aware, right? Maybe you would have studied something like this also, 2 pi f. So you can write this one like this here. So which should be 2 pi divided by 21.5. So how much will this be? Let us calculate that, which will be 2 pi. Let me cancel this. Where is this? Which is 2 star 3.14 divided by 21.5 will be 0.292 seconds. Or maybe if you want it for one significant figure, you can write 0.3 seconds but how is it being asked over here? Let us look at this here. So everywhere it is around the 2 significant figures, so you can keep it as 0.29 seconds. Then next question in that, let me continue. So this is what I said, you have a part of this question related to EMI. IB1 students, if you have only done electricity, electrostatics, magnetism, you will not be able to do this part, but anyway you can look into it. Okay, but if you have already done your IB2 also, if you are an IB2 student, you would have done by this time this one, so this will be easy for you to understand. Okay, a uncharged charge plate capacitor C is connected to an EMF of 12 volt, a resistor and another resistor of resistance 20 megaohms. So you have an electrical circuit like this. R is given here, 12 volt is given here, 20 meg is given here, and capacitance, and you have something like this. Okay, these are three open connections over here. Now what do you do? At t equal to 0, switch is connected on X. On the axis, draw a graph. To show the variation with time of the voltage VR across R. So how is the voltage across VR changing with respect to time? So what you need to do? You need to do something like this. So when you connect at time t equal to 0, when you connect it like this, then what will happen? Just a moment. Right. Okay. When you connect this one here, what will happen? The current will start flowing from here. It will come like this. It will charge the capacitor, and as a result of it, all the voltage will get dropped across the capacitor, and the voltage across the resistor will become lesser. Now, does it immediately charge the capacitor? No, it doesn't charge immediately. It will take some time for it to get charged, right? Why? Because the nature of the capacitor says whether it is to charge or to discharge, it will take some amount of time, right? So, which you have already studied, the time required for it to charge or discharge is not instantaneous, and this will take some time. The time of the way how it charges is given by the formula Qt is equal to Q naught into 1 minus e to the power of minus t by RC, right? So therefore it will take some time for it to get charged. So now what we do is, let us come back here. So based on this, you can say it will take some time. So when it is getting charged over here, so slowly there is no potential drop here. Potential drop slowly becomes 0 over here, and hence what can happen is, initially the voltage across the resistance will be very, very high. See, I am plotting a graph of voltage across the resistance, not across the capacitor, so which is very high. But as time progresses, when all the voltages is now getting built up across the capacitor, so this voltage starts dropping down like this. This starts dropping down like this, and it resembles a smooth curve and goes to 0 after some time. This is what can happen. Okay, this is the graph for this. The switch is then connected to Y and C and discharges through 20 megaohms resistor. The voltage VC drops to 50% of its initial value in 5 seconds. Determine the capacitance of C. Okay, now what happens after some time? Once it is being completely charged, I take this switch. I remove the switch from here, and I connect it here. When I connect it here, what will happen? The charge is present in this capacitor will now start flowing like this. It will flow like this. It will keep on flowing across it. Since there is a resistance over here, what will happen? After some time, the charge built over here will now pass through it as an electric current, and thereby all the current will flow through it, right? And all the current will get dissipated over here. Okay, now what we will do is, let us start with this. Okay, anyway, my camera has gone off. Anyway, the switch is then connected. So voltage VC drops to 50% of its initial value. So what happens? You can now write the formula is VC equal to V naught e to the power of minus t by RC. Okay, so what is VC? The voltage VC drops to 50% in 5 seconds, in t equal to 5 seconds. At t is equal to 5 seconds, your VC becomes a V naught into 50%. What is V naught into 50% means? This should be equal to V naught into 50 divided by 100. So this will now be equal to 0.5 times V naught. I will substitute here 0.5 times V naught is equal to V naught e to the power of minus 5 divided by R into C. Okay. Now what is the value of R? What is the value of R? R is 20 megaohms. C, the value of C is unknown. Do we need to find the value of C? See, determine the capacitance C. Okay. So we need to get the value of C. So this V naught and this V naught goes away. So I will write this 0.5 as half, or maybe I'll just keep it like this and I'll write, just a moment, let me remove this, what you call my camera. The camera is unable to remove. Okay, I got it here. Okay, so this would be, I'll take ln on both the sides. Ln of 0.5 is equal to ln of e to the power of minus 5 by RC, and then I will have this as, what is ln of 0.5? This is 0.693 with a negative sign. Okay, if you do it using calculator, you will get this. The standard value, so I know this ln of 0.5 is nothing but ln of half, which will now be equal to minus 5 by RC. This negative goes away. So thus you have R into C is equal to 5 divided by 0.693, or I need to get the value of C. This should be equal to 5 divided by 0.693 multiplied by R, which is nothing but 5 divided by 0.693 multiplied. What's the value of R over here? R is 50 megaohms, right? Let us go back to this. It is what's the value? 20 megaohms. I'm sorry, 20 megaohms. So I'll substitute this as 20 into 10 to the power of 6, which can be written as, now what we do is we need to calculate the value here to get the value of C. How do I get the value of C? C is nothing but 5 divided by 0.693 is equal to so much divided by 20. I get the 0.36. 0.36, and this 10 power 6 becomes 10 power minus 6 unit farad. So C should be equal to 0.36 into 10 power minus 6 farad, or 10 power minus 6 farad, or this should be 0.36 microfarad. Let me look the marking scheme. Marking scheme also says it is 0.36 microfarad. Okay, so with this we come to the end of today's problems. Okay, thank you. Let us see in the next video more about this. Thank you.